We rolling? Rolling. This is going to be one that Jarrett and I like the best. It's going to be winging it, and Chris likes the least. But I'm going to say this up front. I owe Chris an apology because evidently Chris sent me something yesterday to where I wouldn't be I wouldn't be winging it so much if I had read all the information he had put together, and I didn't. So sorry about that, Mullins. So all of his work went for naught, and so I messed that one up. So my bad. Sorry. Okay, so we just had Thanksgiving. I hope everybody had a great Thanksgiving. I hope you're not like me. I did a lot of thinking over Thanksgiving, and I probably shouldn't have done that. But I was just realizing I'm not nearly as thankful as I should be for everything I have. I think that goes for a lot of us, but still, for me, I was just like, dang, son. I said, you got to be a little bit more thankful for what you got. And then I read 2 Corinthians 9:15. And Paul says, thanks be to God for his indescribable gift. And then that really made me think what I'm really thankful for. And it also was very interesting when I looked into it. This is the word right here that Paul used for indescribable. I'm not even going to attempt to pronounce that. But what is so cool about that is that word doesn't appear in any ancient writings anywhere. Cannot be found. So Paul literally had to make up a word for how thankful he was for the gift of Christ on the cross. So I thought that was pretty cool. So that helped get me a little bit into perspective. So I hope everybody had a great Thanksgiving. Hope they were thankful for what they have. It allowed me to do a little thinking about what I should be thankful for. So I'm thankful for these two guys for all the work that they do, even when I don't do my part. But and then I'm also thankful for all of y'all out there, for our customers and the relationships we have. And it's a lot more than just a business relationship. We've got family out there. So I'm just going to throw a quick one out there. Try not to get too worked up about it. But GT, we are praying for you, love you to death, and know that there are folks praying for you, all right? Okay, cool. So let's go ahead and pray right now, all right? Precious Heavenly Father, I just thank you so much for our time today. I hope that we, at no point in our lives, would get to the point of being unappreciative for the sacrifice that was made for all of us, every single person. And it's out there for us if we just want it. It was a gift. It wasn't shoved down our throats. It's a gift, and it's there for us if we want it. And Father, just thank you so much for these fellows, the work that they do. Thank you so much for our family and friends out there that are working in the midst of all this between Corona and now the weather's starting to come in some. And just please, Father, just let them get home to their family safe. And we've seen a lot of spikes at our reps and our family of customers out there, and we've seen spikes of the COVID. And just the tough part of all this is the waiting, Father. That's the worst part about medical stuff, is waiting to get the news or find out or whatever. So just, Father, give people comfort in the midst of all that. And most of all, thank you for that indescribable gift for your Son, Jesus Christ, because all of these things I say and ask according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Cool. All right. So Ray Gore gets a call on the phone. Ray Gore, they said, man, I'm having trouble, Ray. And he said, okay. Ray says, what you got? And he says, I got a 5S. Ray says, okay, here's what you do. Blah, 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 right? No, that literally starts the questions for Ray, because for us, on the other end here, that 5, just saying it's a 5S meter hasn't really told us enough for us to even try and help you that much. We have lots of service types involved, the applications you're using it in. So, where's my click? Oh, I'm going to grab my clicker. Okay. So that's what we're going to talk about today. The versatility of the 5S can be used on a lot of service types. So it's both easy but difficult. It's funny, but it is easy but difficult. To go out and test it, if everything's okay, it's not that bad at all. But now wiring it up, you may have to do some extra wiring at the test switch, or they may have done some stuff at the actual meter manufacturer to make it work right. But there's some stuff going on there. There's had to be some extra work because it is so versatile. So you have to have plenty of ways you can connect it. Okay, so let's take a look at that. So, well, first of all, this is a, 17, Series 17, crazy. Okay, so here's our agenda. So we're going to talk about 5S meter variants, the 35S and 45S, because those are out there. So we'll talk about differences between them and compare the three. We are going to review the supported service types for 5S meter, and then we're actually going to do some live tests and show you what the equipment will show with different error scenarios and different connections because it's very important to make your connections, between a grounded and non-grounded. So we're going to go over all that, the connections-wise, here at the test bench, training bench here in a minute, okay? So first of all, 5S basics. It is a transformer-rated meter. It has 2 voltages and 2 currents, okay? It is the most versatile meter created. You can see from what Chris and I were talking about this morning, just by either internal connections they make or how you make the connections and connect it up, you can use this on just about every service type there is. Isn't that what you said, Chris? Just about.
I haven't found a service type where it's not been used on.
Right. So that's pretty darn versatile, right? So here are the 3. You've got 5S on the left, and then here, middle and right, I got 35S and 45S. So one thing really quickly, the differences that have been made, if you look at a 5S, most of the differences are made at the test switch. Okay, so that would involve you and I, field guy, us out there actually doing that wiring at the test switch. With the 35 and the 45, that's actually done at the factory. They've made those internal changes there. But the 5S is accomplished through the test switch. Whereas this is the 35 and the 45, it's accomplished at the factory, and they do these internal wiring. So you can see right there. The difference you can see on the 35S and the 45S, if you've got these 2, you can see the 2 neutrals right there connected up, right there on the 35S. Okay? Then on the 45S, we actually have 3. We'll go into it. 35S. It was created to replace a 5S mechanical and to add support for the auto-ranging voltages. So with the 5S mechanical, it wasn't auto-ranging, it was 120 volt only. So one of the big things that came in when we could put the electronic meters in there was it became auto-ranging at that point. So you could make it an auto-ranging going from 120 to 480. So you didn't have that before with the 5S mechanicals.
Yeah, before then they had to put in a PT to drop the potential down. This auto-ranging,
Yeah.
they can eliminate the PT, which is cost and complexity.
Absolutely.
At the service type.
Absolutely. And with PTs, having to involve PTs in there if you don't have to, that's an added, as Chris said, an added cost and an annoyance, gas me. So 45S. Okay. So it was created to help support a 4-wire delta service, and it actually does use 3 voltage phases. You can look back over here, and you see the B that wasn't there for the 5 and 35. There we go. So you can see, I'm going to go over there and point like y'all can see it. So anyway, you can see, yeah, it's not that live, is it? So you can point at you can see the B right there where we have B phase that we don't have on the 5 and the 35.
Yeah, so that neutral common, that tab at the bottom right, notice that you have A and C tied to that neutral phase so they can get, not only can you get your auto ranging, but this allows to get a high leg that you
Right.
needed for a 4-wire delta,
Sure.
which wasn't possible with a mechanical meter.
Right. Cool.
And when I say high leg, I'm referring to the 208 leg or
Yeah.
wild leg, sometimes people
Yeah.
call it.
Hot leg, high leg. Yes, sir. So here's a 3-wire delta ungrounded. And as you can see here, the way that we make the connections, we just get on A and C phases right there. Remember, from what you guys, all of these webinars we've been doing, up there at the top, it's showing you where you're going to measure your primary with your, either flexible CTs or high volt probe, whatever it is. So it's showing you where to pick up your primaries at the top, and down at the bottom it's showing your secondary connections. So you can see here, we're just on A and C phases for a 3-wire delta ungrounded. Okay? Now for a 3-wire delta where a B is grounded, or on our equipment, it'll say a 3-wire delta grounded or a 5S grounded. So you look for where it says grounded. And so what that means is if I've got a B grounded, my B phase grounded, you can see right there the connection over here in the very bottom left-hand corner, you see where I've connected my B phase to ground on the diagram. And this gets important. The reason why we're talking about these is you're going to see in a moment the connections. So when we start making the connections, it's going to be different connections with these different configurations.
Yeah, this will come in later, but we'll talk about, for an ungrounded delta, you have phase-to-phase relationships on your potentials. As soon as you add that ground, that phase-to-phase goes away. Now I'm tying it to a neutral phase. So instead of VAB, I'm now VAN on a grounded delta phase.
Right. So then a single-phase 3-wire, you can see here, it switches now, right? I'm not on A and C anymore. I'm on A and B. Okay, so you can see right there, I'm red and yellow now instead of red and blue. So now I'm on my B phase and my A phase there, okay, for a single phase 3-wire. Then you have a 3-wire network, which looks, you don't see any differences between that and what we just looked at. Then you have a 4-wire delta, 2 CTs, and then you have the high leg. So you can see here, this is with a high leg, a C high leg. Running those out there. So you got a C high leg. So you can see, we've talked about this before, but you haven't seen it much with actual live demonstrations with us. But we've talked about how the Powermaster will show you the different connections, and I would guess anybody's does. It should tell you that for the primary connection sometimes, like in this case, I have to double wrap, right? So it'll literally tell you that at the top. Or I might need to the figure 8, and we've done that before where we've figure 8 and showed you how you can flex and figure 8 our red CT, our flexible CTs. So if you look at this diagram, actually it's got, you can see over here, I've got it says, like we've told you before, it'll do it. It tells you the figure 8 A phase right there. You can see where it's got figure 8 over there right below it. So I would be figure 8ing A and B phase right there, right? I would form the figure 8 with that flexible CT, and I'd have B going through one side and A coming through the other side. Then you can see over here I've got double wrap. Now if I go on that side of the connection, I have to double wrap C phase. If I come on the other side of it, I can single wrap it. But it's showing you, because it is that high leg, if I was going to get on the other side of it with that primary, I would have to double wrap it. Okay, so it's showing it is positional as far as whether it needs the double wrap or not, where you're placing it. Okay? So now you actually get to see an example of where we talked about it before, where it'll say double wrap and it'll show figure 8s on the diagrams where you can see them right there. That's what we've been talking about in the webs. If it was a high leg, then you kind of swap it, it all jumps up to the A now, right? So now I can double wrap over there on A phase before or after, depending on where I make the connection, or it's single wrap on that side of the transformer. And then over here, I do my figure 8 on C phase. Perfect. Thanks, Jared. So you can see there, that's where we do the figure 8. So that's what it would actually look like on the screen. We've talked about it, but I don't think we've actually had that many live, have we? Or where we actually get a lot of figure 8 and all that stuff. We haven't done that much.
We did one webinar on the 4-wire delta 2 CTs VC high. We did one webinar
Right.
on that.
So,
that seems to be fairly common, we found.
Yes.
Yeah.
So now they get to see it even more, because this is what I'm talking about. It'll actually, that color diagram, man, if you go out there and you don't imagine when I was thrown out there, I grabbed onto that thing like a life preserver off the Titanic. I mean, I love that. Between that and Ray Gore, that's what got me through in the beginning. So that right there, it's actually literally showing you what you have to do depending on where it's a high leg or C high leg. Okay. So I got 4-wire Y, 2 CTs. So you can see here, it's showing me that I've got to figure 8. I got a figure 8 C phase and I got a figure 8 A phase. It's showing a figure 8 on both those. Now, for whatever reason, it didn't right under there figure 8, but it would normally have that. It would say underneath there figure 8. Okay, so you can see I got a figure 8 on A and a figure 8 on C. So what we're doing there is that's exactly what we've talked about before, right? If I'm using B as my reference right there, if I figure 8 the two of them, it'll be going both ways the wrong way, right, through B phase. So I'm measuring A and C, and I'm just using B as a reference. So because of the way I figure 8'd it at the top and the bottom, the two connections of the two different flex probes cancel one another out on B phase.
Yeah, you're actually splitting the current from B phase into A and C, so you can summate the two
That's
other
right.
active phases.
Exactly right. So
Summate, is that a word?
it is now. It is now.
Sounded fancy.
Write that down. I liked it. All right, so let's go ahead and do some of these connections. How do you want to roll this, Mullins? I'll just we'll start out.
Yeah, so we're going to start out. So John's going to kind of go through connections. If we pull up to what we think is a 5S 3-wire delta, ungrounded, we're going to start that process.
Okay.
Going through connections, and let's do some troubleshooting on what happens if I don't have a common, or I've got my common set up wrong
Sure.
or hooked up wrong.
Sure. Okay, so I roll up on the site, and this site is supposed to be a 3-wire delta, right? So Mullins has sent me out, and he said, go out there and check out that site. It's a 3-wire delta and see what's going on. You got it, boss. So I'm out here, and you can see I have my connections here. I'm on A phase here with my voltage. You see right here, I'm on A phase right here with my voltage. Okay. I'm on C phase, because remember we talked about C phase, right? A and C phase, so we know we're on that. But look what we got going on here in the middle with B phase and my neutral. Okay, I've got my B phase and I've got my neutral connected to the same point right here, right? On my bonded neutral. So I've got them both grounded to my bonded neutral right here. Okay, so I'm on A phase and I'm on C phase, on the A phase voltage and the C phase voltage, but I've got my B phase voltage is not connected over here on B phase, it's connected right here. Okay, so it's connected right there on the neutral. So I've got it right there on the neutral along with my neutral connection. Now, I'll just tell y'all my standard rule of thumb is on all of these, I have both my neutral and my B phase on there. Okay? I don't leave anything hanging. Okay? Some folks, I've seen them before where if it's not, they'll just leave it hanging. I'm not big on the leaving it hanging. And let's start right here. We'll give you an example. So this is just a standard 3-wire delta that Mullins has sent me out on, so I'm out here. So you know what we always talk about is hitting the vector diagram first, right? So we can see what's going on. So I'm going to hit the vector diagram first. Ooh. Did I mess up the tilt? Am I good now? Cool. Ooh, Mullins was starting to come out of his chair. That wasn't good. All right. Okay, so this is a standard 3-wire delta. I've hit my vector button. Remember we talked about hitting your vector button ahead of time so you just look and see what's going on. I'm showing 120 volts VAB, 120 volts VCB. So we're using that reference of B off of them, right? So all that looks okay. Let's do something real quick. What if I did leave that B phase hanging or didn't connect that B phase or this neutral? Let's try that real quick. All right? So if I take the B phase off of it and I just leave it hanging, what am I seeing over here on my screen now? Now I'm not seeing a huge change, but did you notice that my voltages went from 120 volts to 114 volts here? Now someone might think, oh, must have PTs or something up there. No, that's not the case. This is where, remember, stop, think, kind of look for a minute and see what's going on here. If you went back to that color diagram, if I go to a color diagram I'm going to look at here in a minute, I should have that B phase connected. Right? I don't need to have it hanging like that. So notice the difference when I come right here and I connect it back again. Now I've got my 120 volts, which looks good, so now everything looks good again. But notice that was kind of wild, wasn't it? It didn't change the vectors up crazy. The vectors didn't go crazy, but those amplitudes changed. So you got to watch everything on here. I mean, we talk about amplitude and we talk about the direction of the vectors and the relationship to them. This is one of those cases where if I left that disconnected right there, I wouldn't get a true reading, right? And I might think that I'm getting one, but that 120 to 114 was a clue. It gave me kind of a, wait a minute, what's going on here? Because I could have rolled up there and just left that thing hanging, and then when I connected it up, now it jumps to 120, right, where it should be. Okay? So we see our connections again. I'm on A phase here for my voltage. I'm on B, with my B phase voltage connection, I'm on my neutral, and I've also got my neutral connected there. And over here on C phase, I'm over here at my C phase. Now, what about my currents? My currents are A and C because that is the standard 3-wire delta 5S, right? I'm on A and C phases right here. So I'm on my A phase ductbill right here and my blue or C phase ductbill right here. So I've got A and C for my currents, and I got A and C for my voltages, but also a grounded B for my voltages. Okay? Cool. So this is, and we'll run, you want to run a test? What do you want to do on this, Lawrence? Think we need to run a test? You're the boss. I've called into the shop. What do you want me to do, man?
What happens if we don't have a neutral hooked up?
Ooh, okay. Nothing changed, right?
Nothing changed, because why is that? Because we're going VAB,
That's right. Because B is our reference now and not the neutral.
Yeah, now take off B phase.
Yeah, now B phase will do what we said before, right?
So we have no common anymore. So notice how the vector can't stabilize because there's no common phase anymore. So if there's for any reason why you lost a common phase, the delta will still operate because it's a 3-wire delta, but when you look up in the vector diagram, on a test piece of test equipment, it's going to look jacked up.
Yes. So right here you can see big difference in the vectors, right? We know that's not right. Okay, and remember, you always have the reference buttons that you can always push to take a look at them. So here's the reference button, so I've hit the reference button. Yeah, see? Looks just a little bit different, all right? So big difference in the vectors, right, from what it should be to what it should be. So you can see the big changes we had if we didn't have these connected correctly, my neutral and my B phase. Okay, so I'm going to go back here and I'm going to connect my neutral, and I'm going to connect my B phase back up. Okay.
So now what I'm going to do for John is I'm going to switch the service type where B phase is actually grounded and see how those same theories of connecting the voltage neutral and voltage B to that same common point to see if it makes any difference.
Okay. Gotcha.
So then, John, you got to change it service type in your Powermaster.
So you've told me the service type, so I'm not having to discover it when I get out.
Right.
Okay. So I'm going to deselect the site so that I can go back here. We've got a site in there that is a 5S delta with a ground on it. So we'll go right there and hit select. So now I'll go ahead and hit my vectors. Okay, so my vectors look okay. So I'm not upset with my vectors. They look okay. But this is a grounded system. Now remember what we just went through. We just said we were using B as our reference now, but now this is a grounded system. So what's going to happen now when I take B off? This is the reverse of what we had earlier, right? When we took the neutral off, nothing happened. Now when I take B off, nothing happens, right? Because neutral is the key to it now, because we said this is a grounded. Okay, so you have to have that neutral connected. If you don't have the neutral connected, we should get whammy what we got before, right? So it's the flip inverse of what we had before, right? So when you have a standard 3-wire delta, okay, you need to have that B phase connected, right? If you are on a grounded, you don't have to have the B phase connected, but you have to have the neutral connected. Okay, so the two of them are flipped as far as that B phase neutral connection, which is the key to the whole thing, is what you have to play with these 5S's, okay? So in this case, if I just connect my neutral, everything's honky-dory. Okay, but I can connect this as well. I can put my B phase on there if I want. It's not going to hurt anything. Like I said, I always roll that way. So there we go. So that looks a lot more normal, and that's what I want to see, right? Looks just like the reference when I hit my reference button earlier. So everything looks okay on that one. So that would be a 5S 3-wire delta grounded. And we chose that there is a different service type in for that, okay, on the equipment. You have to make sure you choose the right one. But also, remember, and we preach and talk this, the most important tool you got right here. These and this, okay? So just think about it for a minute and remember the difference on the B and the neutral connections, okay? If it is a standard 3-wire delta, standard one, okay, you have to have B phase connected. It's your neutral. If it's a grounded, you have to have the neutral connected. Okay? That's why I just connect them both. So I'm covered either way. Okay?
Yeah, the key point to remember is that the big difference between the grounded delta and ungrounded is that the power pairs change when you select the different service type file in the Powermaster. So a ungrounded delta, you're referencing A to B, C to B. Mm-hmm. And then on a grounded delta, you're referencing A to neutral, C to neutral.
That's right. So everybody catch that? So, and it'll even say that if you look on the diagrams and stuff, it's going to say VAB, right? So it's because it's talking VAB, VAC, right? And that's when I'm referencing off of B when I have to have B connected. When I don't, when I have to have the neutral connected, that's going to be VAN and VCN, right? So cool. Okay, so everybody's cool on that. So the big difference between those two is that B phase neutral connection and how it affects our vectors on here, okay? So if it is a standard one, you have to have B connected at the ground. If it is a grounded, then you have to have the neutral connected, okay? The other is superfluous, but I will go ahead and put them on there. I connect both of them, and that way I don't run into problems, whether it's a grounded or ungrounded, okay? All right, so now Chris is going to throw another one out there, and we're going to check it out.
Yep, I'm going to throw him a scenario.
All right, an error scenario. Okay.
Okay, ready for you to start.
All right. So we got all our connections. I've got both A and B connected right there. Talked about earlier, so I got everything hooked up. So let's go ahead. What do you want tested, Chris? Do you want a meter, CTs, both? What?
Let's check our vector real quick.
Okay, let's look at vectors. We were going to do that anyway, because you don't always do that. Oh, I got hit my button. All right. So right now the bench is lining us up. Should be ready here in just a second. Okay, surely the bench is going to get it lined up here in a minute. Oh wait, I think the bench has already got it lined up. It's just really jacked up.
Yep,
So,
the bench is active.
So
what's going on?
Mullins didn't just throw me a curve. He threw me a major league yacker. So this is jacked. Okay, so I'm looking at the vectors, and I know they're jacked up. So that doesn't look good. Okay. I tell you what I'm going to do. I'm going to go ahead and run. Let's go ahead and try and run a test and see what happens. See if I can pick up pulses. Because remember, we're going through our little process in our head. I already don't like the vectors. So I know there's a problem. Okay, now, let's talk about something real quick. When we talk about problems, and remember I always say I default to John first. So I always worry that I've got something not connected correctly. So when I see something like that, I immediately step over here and I look at all my connections and I go, all right, A, B, C. Okay, so all that looks okay. Now, if I'm out in the field for the first time, we've already done a couple with this, so I know how they're connected. But if I've only just put it on for the first time, I'm going back and looking, okay, when I get something like that on there. So I'm looking, I go, okay, no, everything looks okay. I come over here and I make sure I got, yep, A phase on A, okay. Okay, everything looks okay on my flexes. All right, so, okay. So I'm going to go on in, since I don't see any connection problems, I'm going to go ahead and go into a test. So I'm going to, let's do an integrated site test. Well, I'm sorry, what do you want me to do, boss? You want me to do meter and CTs or just meter?
Let's go ahead and do both, see what we got.
You got it. Okay, so I'm going to go number 2. And I got a double wrap. Check my double wrap box, because they are double wrap. My flexes are. And then we'll go back right here. And I always put in 30 seconds or 3 revs. Okay. So let's go next. Oh. Okay. That'll work. My case of tea. One. There it is. Perfect. Yep. Okay. So it's showing me my connections all look right. I'm on A and C. I'm on the neutral. Okay, all that looks okay. Man, I still don't like those vectors. Okay. Let's continue. Okay. Well, that's not giving me anything jumping out at me so far, is it? 99.968, that's not jumping out saying, up. You got a big problem there on trying to get registration. So my pulses and my power are lining up with one another, right? My pulses and the case that you have put in there is a 1.0. All that's lining up, okay? So it's acting like, no, it's 99.977. That's pretty darn good. So it passed the meter test. So all those numbers are falling in line, so that looks okay. So let's go next test. Okay, so we're going to test the CTs. So we got them on A and C, so we're good there. So we hit next. Dirty dog. Okay, so Mullins has got a good one. So, possible polarity reversal. Okay. I bet they've left, they left C disconnected here.
No, you're right. That's correct. That's as expected.
Okay. All right. Let's stop and think for a minute. Okay, I'm looking at this and I'm seeing a primary amps of 0.07. To me, in the field, that I may as well say 0 on that one. So I'm not getting any C phase current, primary current. So I'm missing out on my C phase current, right? Okay. Let's stop and think for a minute. We went through those three types earlier. We went through all these different types, right? We went through the different types and showed you the differences between the different types. So when we went through those, you noticed that there was a change. Remember when we talked about that change of our connections? Or we made a change of connections from A and C to A and B? You remember when we had to make that change of connections? When we were going through those diagrams? So if I'm out in the field and I'm not getting anything off C phase, so it's showing me 0 primary, so I don't have any current come off C phase. And I remember in one of my diagrams, I wasn't connected to A and C, I was connected to A and B. So that was on a single phase 3 wire. So I'm going to step back and I'm going to look up at the top of the pole and I want to say, hey, I think this might be single phase. So I'm thinking that what I might do is, since I'm not getting anything off C phase, if it was actually a single phase 3 wire, it would be looking for B phase, and there's no B phase, right? So it was looking for C, it didn't see anything, it says, nah, that's not good, we got a problem there. But that's because I'm connected, let's think about this for a minute, I'm connected on A and C phases, but if we went back to, here, and I'll let, y'all have the clicker, could y'all go back to that diagram real quick? Go back to the diagram, Chris, and let's look at a single phase 3 wire. So on the single phase 3 wire, I should be connected to A and B phases. Well, if this is a single phase 3 wire and I'm connected to C phase, then that's why it's going to give me nothing coming off C phase, because I should be connected to B phase, right? So that right now I'm thinking is my number one culprit. So let's go ahead to do that. What I'm going to do is now I'm going to go back in the machine. I'm going to choose a single phase 3 wire and I'm going to change my connections here and we'll see what happens. All right, let's try that. So I'm going to go in here. Deselect this site. I'm going to put another one in there. Let's go to, let's try 5S single phase. Let's try that one. Okay. Now I need to move my connections, right? Because remember we said we're not on A and C phases anymore. We're on A and B phases, right? So I'm going to disconnect my C phase. And I'm going to have my B phase disconnected here. here. Up here. Let's take a look. We got A phase. So I got A phase. Oh, shit, up here. Should be there. All right, let's hit our vector diagram. Oh, gotta go one more step. Come on. So B phase. So here's my A phase. Here's my B phase, right? Here's C phase is sitting over here. So let's look at our, let's go previous. Let's go to an integrated site test number 2. And we will go here, put in 30. Go here, check that, and then let's go next. All right, so it's showing here, right, that I should be on my secondary voltages A and B, which I am right here, right? I'm on A and I'm on B, right? And then on my secondary, it's telling me my secondary currents, it's my voltages, I should be on neutral A and B, my secondary voltages. So all that looks okay. My currents. Let's see. Let's look here. Secondary current A and B. Okay. Secondary current A and B. So I got both the duct bills in. I got C. Hold on a minute. Let's open this. This. I like that better. So I got A and B right here. So I'm just going straight off my color diagram. So I got my secondary currents A and B, my 2 duct bills A and B. I've got my secondary voltages. I've got A, B, and neutral. So I've got A, B, and then my neutral connection. Right? There. Okay. Connection now. All right, so let's go to next. Okay. So let's say you're out there and you're like, yeah, all that looks okay to me. Is there a way that I can double check that? There is, but remember I talked about hitting that, if you hit your vector button before you get into a test, you have the reference button, the other buttons you can hit, right? Well, right now I don't have that. So what I can do is, if I wanted to, I could previous out. Just show y'all how we could do this. So we're doing troubleshooting here. So let's say that I wanted to hit my vectors here. So when I hit my vectors, now when I look at it, see, I can hit my reference button right here. So everything looks cool, right? So you always got a way that you can check, all right? So you can always check this stuff. So all that looked okay. All right, so let's go through what I just did by moving that connection over there. Let's talk about troubleshooting out in the field when we're looking at it. Okay, so when I switched over to this, let me go back to my reference. Oh, thank you. So let's bring this out of here. Let's go back to here. So there's my reference view, and if I look at reference view, it didn't change either way when I just made that change in that connection, right? But let's think about this. We've swapped out our A and our C connections, okay? So it doesn't show a difference on the vector diagram. So whether you have this or this connected, that's interesting. Okay? But we know that we're dealing with A and B now, right? So we're going to have B connected there. Now, let's hit this table button right here. So you have ways of confirming not only your connections, but you have, like we were talking about here, not only just the general connections, but a difference between something like this, which can be specific to just A or B phases being the one that you're referencing off of here. Okay, so you got different tools that you can use. Okay, so we're looking at this now. Too far, too far. Oh, that looks good. Okay, so let's go previous. So let's try a test now. We're going to do an integrated site test.
Let's back up. Remember that we were dealing with a single phase. We figured out it's a single phase service, right? There wasn't
Yes.
necessarily an error. We just had the wrong service
Yes.
type file selected in the Powermetrix.
Right.
So why, when you had the yellow on the neutral, what amplitude did you have on the vector diagram?
When I had the yellow on the neutral before we swapped over.
For VAB, what was the amplitude? 120.
Yeah, it was 120.
Right. So think of this kind of like this is basically simulating a single phase 3-wire, like a 4S service type.
Okay.
So we're using a single phase service using a 5S meter, treating it like we would a 4S application. So with a 4S application, you have two potentials phase to phase, which is A, VA, and VB, and they sum together to equal 240 volts. So once you move your B phase over into your other reference phase, now I've got A and B together, and it's measuring that 240 volts, as opposed to that A in common, which is measuring half of the potential.
Ah, okay. Well, that's great. Thanks. So you can use the tool of this. We can use the tool of what we had a minute ago, this RMS table, and you can hit the RMS table and you can look at the voltages and see the difference between them. Okay. Gotcha. Okay, so it's 240 now. I got you. Okay. So move it over here. Nice. Okay. So we can use this table also to check our connections, right? Just what Mullins just said now. I'm showing 120 when I'm here on the neutral. But when I go all the way over here and get over on the hot leg, and now go to 240. Nice. So we can use the table as well. We talked about using the vectors a lot, but we do use the table sometimes, and this would be a case where the table would point it out to us, the difference between the 120 and the 240.
Now your registration will probably still come out 100%, but your total accumulated KW would be wrong.
Right, exactly. It's only getting half. Gotcha. Cool. We can go ahead and run a test. All right, let's go over here and make a couple of changes. 30 seconds. And we'll also get over here. Wrap, and boom. Okay. Okay, we look okay there now. What's it going to be? 99 point?
97.
Oh, nope. 119.
Oh, check a KH.
See, I saw that on there. It was 1.2. Yeah,
That makes sense.
That makes sense. So it all worked out. Did y'all see that earlier? I saw that myself. Look over here. It's going to be 1.2 on the K sub H. Okay, I've been out on the field with the guys, and this has happened. So we'll talk about that for just a second, since we're talking about advanced stuff. I've been out there in the field before where I went out there to test 9S meters, and, and I put in my K sub T, and I'm thinking everything's fine, and I'm putting in my 1.8, and my numbers were off. And it consistently happened at 3 sites. We thought, well, maybe there's a problem at that site. So after the 3rd site, I went, okay, let's go back to the 1st site. Went back to the 1st site, and I got looking at it, and you can do the math in your head, and you can figure out about how much it's off, and you can say, well, wait a minute, did you guys program this meter for 1.8? So they called up the boss, it turned out, and the number I had in my head was around 1.4, and he said, no, we programmed those for 1.4. Wah, wah, wah. So that's the deal. So that is what can happen to you, okay? Don't assume anything on these case of H's. And when I saw that 1.2, I saw 1 on the first one we tested, I saw 1 on the second 1.0, and then I saw this one 1.2, and I went, and it was right as I was hitting the button. So I should have stopped it. I didn't. But it makes sense, right? I had it, it's 1.2 instead of 1, and what's my registration? 120 instead of 100. So you can do that in your head and go, wait a minute, something's not right here, and you would check that case of T or case of H, okay? I've had it happen to me in the field where they programmed that meter with a different case of H or case of T, or it showed up from the factory with a different case of H or case of T, and they just left it that way. That's the way we program in the system. So when the numbers work out in your head, wait a minute, and in my case, I saw 1.2, it should have been 1.0, and sure enough, my registration is 120 instead of 100. So let's go back.
And on that same subject of programming the meter, I've seen this happen before, is that sometimes, because the 5S is so complex, well, as far as all the service types it can support are so complex, that not always, the meter is not always programmed for the right service type. So like GE's, I'm sorry, not GE anymore, the old GE KV2Cs, you had to actually go in and select the service type you were going to program for the meter. And if that's incorrect, that means the metering is incorrect.
It was 1.2 right there, like I had seen. We'll see if I had hit the reset button. Let's go here. Let's go next. Hopefully it took the 1.0. Yep. So 99.918, we can go with that. So here's let's go over real quick the highlights. Here's the summary. The 5S meter is extremely versatile. 5S metering is easy. It's just the wiring to the CTs and the test switch that make it complex. Yeah, depending on, and the meter manufacturer is going to have to do something internally. And then take care to properly locate your common phase based on the service type. So let's go over the highlights just real quick. Okay? So the highlights were the difference here on my connections on the 5S meter forms of my B phase and my neutral. Okay? So if it's a grounded B phase, then I have to have my neutral connected, right? If I don't have my neutral connected, I'm going to have a problem. I just connect my B and my neutral at the same point for these two, whether it's grounded or ungrounded. It'll work either way, because in the other, on the standard, the non-grounded, you have to have B connected at the neutral or you're grounded. So I just connect both of them, and that way I'm covered on the grounded or the ungrounded, either one, okay? But remember, that's the way it works if you have both of them. So maybe you use that same little trick I do. I just connect both of them, then I don't have to worry about it. Okay? Now let's say if you rolled up on a 5S meter and you didn't know it was single phase. Okay? So to what Mullen said earlier, if you noticed, you could go to that RMS table and you can hit that table, and if you hit that table, so we say before you get rolling, hit your vector and hit your RMS table in case you see something that just doesn't look right. Well, if you hit the RMS table for the single phase, it's going to show 240 volt, okay, as my voltage is all the way across the top. But if it's not, I'm going to show 120 volt. Okay, so I would have seen that and said, oh, whoa, this is a single phase. I got 240 volt on all 3 phases here. Okay, so because it tested the same, okay, it tested okay with it connected the way it was. It tested all right until it got over to that C phase CT, and then it went, whoa, I'm not seeing any current. That's because we weren't connected. We didn't have B phase connected. Okay. So there was 2 ways you were going to find that out, either off that RMS table, but when you did that CT test, everything wouldn't have really jumped out at you until you did the CT test. But then once you did that CT test and you came back and went, whoa, it's not showing any primary current at all, that means it's looking for B phase. And that's when you see that problem. If you didn't do it beforehand, definitely hit your vector and then that RMS table button. And if you hit the RMS table button, then you would have seen 240 volt across the top, and you went, oh wait, this is single phase. Okay? The C phase CT test would have pointed out to you got a problem, because I'm not reading anything on C phase right now. And then you would have hit the RMS table and you would have seen 240 volt across the top, and you'd have went, oh, this is a single phase. Okay? So I think the big things to pull from this today are those connections with the B and the neutral right there are critical when you're doing the either the standard three-phase, the three-wire delta, or if you're doing a grounded. Okay, and then if you happen to run up on one, don't know if it's single phase or three-phase, you can just either look up or you can look over here and you can check it out. Okay, so you got different ways of doing it. All right, that's the big thing. And but all of them hopefully give you the same correct answer, which is you want to have it connected correctly here, so you can test that 5S if it's ungrounded. You want to test if it's grounded, and then you want to make sure if it's a single phase or not when you roll up there. Okay, because a 5S can be a lot of things: 35, 45, 5. Grounded, ungrounded, single phase. You got a lot of different services. So we're going to use these and these, right? After we look at this. Hope everybody had a great Thanksgiving, and looking forward to going forward with this. I guess we've got how many more before the end of the year?
2, 3.
Yeah, about 3 of them before the end of the year. So it'd be kind of wild to end up the year having spent most of the year doing it this way. So kind of a crazy year, but. Just everybody, we really appreciate you so much. Thank you so much for the support. Thank you so much for all the feedback we've been getting. And more importantly, we just appreciate your support just in general in all these times right now. So thank y'all. We'll just keep our heads up and roll on, right? So appreciate you guys. Thanks a lot. Goodbye.